and welcome to this class. In this class we are going to talk about the relationship that exists between the mole and the molar mass. In the previous video we talked about the mole and Avogadro's number. But in this video we are going to talk about the mole and molar mass. So we're actually going to refresh our memory on the meaning of mole. Then we define molar mass, and then we try to create a relationship between the two. So that is our aim in this class. A mole, like I defined in the previous video, that a mole is amount of substance that contains 6.02 10 by 10 raised to power 23 particles of the substance, where the particles could be ions, atoms, or molecules. Then for molar mass, the molar mass is the weight in gram of 1 mole of any substance. Weight in gram of 1 mole of any substance. One mole of a substance. So that is the molar mass of the substance. So what this means is that when we get something like 1 mole of water, 1 mole of H2O, and we weigh it, whatever it gives us in gram is the molar mass of water. When we get 1 mole of hydrogen molecule and we weigh it, whatever it gives us in gram is the molar mass of the hydrogen molecule. When we get 1 mole of sodium chloride and we weigh it, whatever it gives us in gram is the molar mass of the sodium chloride. So whatever substance we have, when we get 1 mole of it and weigh it, the mass of it in gram is the molar mass of the substance. Now what happens if we don't have an instrument to weigh the 1 mole of the substance? We can still calculate the molar mass by using the component atoms that make up the compound or the substance. For instance, for water, H2O, we can calculate the molar mass of water if you don't have an instrument to weigh 1 mole of it by calculating the sum of the hydrogen atoms and oxygen atoms present in water. So for water, we have 2 hydrogen atoms, and 1 hydrogen atom weighs 1 gram. That is the atomic mass of hydrogen atom, plus oxygen atom, which is 16. Atomic mass of oxygen atom is 16. So 2 times by 1 is 2 plus 16, which is 18. So 18 gram is the molar mass of water molecule, of 1 mole of water. This means that 1 mole of water weighs 18 gram. The mole of a substance is equivalent to the molar mass of the substance. It has weight that is equivalent to the molar mass of the substance. In the same manner, if we are given sodium chloride to find the molar mass and we don't have an instrument to calculate or to weigh 1 mole of sodium chloride, what we do is that we calculate the molar mass from the component atoms, which are sodium and chlorine. Sodium is 23 plus chlorine is 35, which is 58 gram. So any substance, once we can calculate or we know the atomic masses of the component atoms, we can calculate the molar mass of the substance without having to weigh it. Now, the relationship that exists between the molar mass and the mole is what I've said before, that 1 mole or 1 molar mass, 1 mole has a weight that is equivalent to the molar mass of a substance, mm. 1 mole of any substance has a weight that is equivalent to molar mass of the substance. So every chemist and every chemistry student must have this definition. 1 mole of any substance is equal to or is equivalent to the molar mass of the substance. For example, example 1, if we are asked to calculate this, how many moles of water is present in 24 gram of water molecule. How do we calculate this? To calculate this, solution, we say that 1 mole of any substance, weigh the molar mass of the substance. Now for water, molar mass is equal to, we don't have an instrument to weigh 1 mole of water, but we can calculate the molar mass of water using the component atoms that make up water molecule. So we have 2 hydrogen, water is H2O, which is equal to 2 hydrogen plus 1 oxygen, 16, which everything is 18 gram. So we say that 1 mole of water weighs 18 gram. Then we go back to our question. They say how many moles of water is present in 24 gram of water molecule. So we are given 24 gram of water and we are asked to calculate the number of mole. Let's call it X. So we now ask ourselves that if 1 mole gives us 18, 24 will be given by what? Which we now call X. If 1 mole gives us 18, X gives us, or what will give us 24 gram. If we place it this way, we do cross multiplication and we have that 1 times by 24 or 18 times by X X times by 18 is equal to 1 times by 24, and so we have that x is equal to 1 times by 24, 1 times by 24 over 18, and so we have that our x is equal to 24 over 18, which gives us 1.33 moles of water molecule. So this is the answer. Example 2. Example 2. How many moles of calcium carbonate, which is CaCO3, is contained in 31 gram of calcium carbonate. How many moles of calcium carbonate is contained in 31 gram of calcium carbonate? We may be given the atomic masses of the atoms to help us or to ease our calculation. Calcium is 40, carbon is 12, and oxygen is 16. These are the atomic masses for the component atoms. Now, solution. We ask ourselves, we remind ourselves that 1 mole of every substance contains or weighs equivalent of the molar mass of the substance. Molar mass of the substance. Now we don't know the molar mass of this substance, so we have to calculate it. Molar mass of CaCO, molar mass of CaCO3 is equal to Ca given to us is 40 plus C is 12 plus oxygen is 16 times by 3, 16 into 3. When we sum this whole thing, it will give us 100 gram. So this means that the molar mass of the calcium carbonate given to us is 100 gram. So we place it and say that 1 mole of the substance given to us is 100 gram. Therefore, they say how many moles of the substance is contained in 31 gram. Let's call the number of mole x. So if 1 gives us 100, x will give us 31. Let's find x. How many will give us 31 gram? If 1 mole gives us 100 gram, how many moles will give us 31 gram? So that is the equation. So we do our cross multiplication again and say that this x will go to 100 and 31 will come to 1. And so we have 1 times 31 is equal to, let's start with the x. X times by 100 is equal to 1 times 31. And so we have that x is equal to 1 times 31 over 100, and this gives us 0.31 moles of the substance. This is the answer. This is the number of moles of calcium carbonate that is contained in 31 gram. It simply means that if 1 mole gives us 100, 0.31 mole will give us 31 gram of the substance. Example 3. Example 3. What if we are asked to calculate this? What is the mass of 0.78 moles of CO2? We may be given the atomic mass of carbon as 12 and that of oxygen as 16. What is the mass of 0.78 moles of CO2? Solution. We still recall that 1 mole of any substance gives us weight that is equivalent to the molar mass of the substance. Then, looking back at the question, what we are asked to calculate here is the mass that will be given by 0.78 moles of the substance. In the previous two we calculated, it was the mole that we calculated, but here we are looking for the mass of the substance. The same principle of calculation applies. So we have to get the molar mass of the substance. Molar mass of CO2, we cannot get it with an instrument because we don't have any instrument, but we can get it from the atomic mass of the component atoms which we have been given. CO2, carbon given to us is 12 plus it has 2 oxygen, 2 times by 16. So we have that the molar mass of CO2 is 12 plus 32, which is 16 times by 2, which is now everything is 44 gram. And so we say that 1 mole of this substance of CO2 gives us 44 gram. Then we go back to the equation. We say the 0.78 mole given to us, how many gram will it give us? That is the equation. 0.78 moles will give us how many? Let's call it x. So we can do cross multiplication here. This going to this and this going to this. And now we have x times by 1 is equal to 0.78 times by 44. And so we have that x is equal to 0.78 times by 44, which is 34.32 gram. This is the answer. So this means that if 1 mole gives us 44 gram of CO2, 0.78 moles will give us this thing which we have calculated, 34.32 gram. That is the answer. So we have seen how to calculate the mole from molar mass and how to calculate mass from mole.